Welcome back, guys, with another tutorial of physics. We have this capacitor of a diameter of 2 centimeter plates, and space between them is 1 millimeter, and they have been charged of 0.5 coulomb per second. So here we need to find what is the magnetic field inside the 0.5 centimeter from the axis. So what are we gonna do here? They went from few steps, and then I will get to my final result. So first thing first, we know the magnetic flux in the electric field is going to be equal to electric field times the area, and this means that electric field is equal PR squared. This is the first step, and the electric field inside a parallel capacitor, we know it's equal to sigma divided by the constant, and sigma is equal to charged particle divided by the area divided by the constant. And if we go further again, we can do the charged particle divided by P R2 multiplied by the constant, and we can grab the magnetic flux, and we can take the electric field and replace it with the charged particle divided by P R2 squared multiplied by the constant multiplied by P part 2. Actually, the electric field, let's make it, I'll make it different, is the radius of the area of the plate, and the magnetic flux is the radius of that area that we're supposed to measure. So don't mix it up in this, don't mix up the two radius. The big R is the radius of the plate, and then we can cancel out the pi, and the magnetic flux will be equal to charge divided by R2 of the plates divided by the constant multiplied by the radius of the area that we're supposed to measure. So this is one of the formula that we're gonna use to find the magnetic field in this capacitor. Okay, so from here we know that to integrate the magnetic field, we have this formula of magnetic field multiplied by the derivative of that area of, let's say, let's say the length of that magnetic field, and this one is equal to the constant multiplied by the current, and here the current is going to be equal to derivative of magnetic flux and divided by derivative of time, and don't forget this one is going to be multiplied by the constant of the electric field. We know the magnetic flux is this formula, so let's replace it in this formula of the magnetic field, and this one is equal to constant of the magnetic field multiplied by the constant of the electric field, derivative of all this area, the charge or square, divided by the radius of the capacitor, divided by the constant, and don't forget is divided by the derivative of time. So with the magnetic flux in this section, we're gonna keep it simple because it's an infinite wire, and this one is gonna be equal to magnetic field multiplied by the length, and this one, because it's a square, we're gonna do magnetic field multiplied by 2 pi, the radius of that square wire. So here, magnetic field is equal to constant multiplied by the constant electric field derivative of the charge divided by the constant of the electric field multiplied by the radius of the area divided by the radius of the plate, and this one is going to be divided to 2 pi radius of the area. So there's two things it's going to be cancelled out, the constant here and one of the radius here. So the magnetic field is going to be equal to the constant divided by 2 pi multiplied by radius divided by the radius of the plate, and then it's we're gonna divide, don't forget here is divided by time, and this one's gonna be derivative of the charge divided by derivative of time. So the magnetic field equal constant divided by 2 pi, the area that we're supposed to measure from the point of charge is 0.5 centimeter, and this one we're gonna convert it to meters divided by the radius of the plate, and that's 0.01 meter, and don't forget it's square. And this one is 0.5 Coulomb second. So the magnetic field is equal to 5 times 10 power of minus 6 Tesla.